In this video, we will continue with solving exponential equations and inequalities. You will find this on page 406 in the Namibian AS-Level Mathematics textbook, y equals mx plus c to success. Let's look at another example. Again, I'm just making it bigger for the exponents. Okay, there it is. Solve the equation, but the problem is now there's a negative. There's not a multiply. Okay, so it's 4 to the power x minus 2 to the power x plus 2 equals 5. Okay, now what we're going to do is we did it in ordinary level also. We call it that splitting. We take this and we write the prime factors of 4. That's 2 to the power 2x. Okay, and this is 2 to the power x. So this we give the base to the x as well as the base to the 2, because before it was actually like that, 2 times 2 to the power, and then we made it 2 to the power x plus 2. So now we are just reversing back, where every exponent is having its own base, and that's what I did there. So 2 to the power x multiply 2 to the power 2 equals 5. Okay, and now I'm just, look, that we call this is a disguised quadratic trinomial, because, can you see, this is x and this is double, so this is 2x. So I look at the numbers, there's the numbers, it's 1, it's 4, and it's 5. Okay, and then I go and I say, okay, 5 times 1, 1 times 1, it's subtraction, so 5 minus 1, it's that 4. The biggest over cross product, get that negative and positive, and I use that exponent, 2 to the power x, 2 to the power x, and that's where I got that 2 to the power x minus 5, 2 to the power x plus 1 equals 0. And I put this equals 0 and I put this equals 0. Now, I reject this, but because you will never get a negative there. There is no solution to the equation since 2 to the power is always positive. You can even see it if you convert it to a log form. Say you take 2 to the power x and you convert it to the log form. Then you're going to get log 2 negative 1 equals x, and you don't get the negative of a log. So I reject that one. Okay, and I continue with this one, and take logs on both sides. So I take logs on both sides, bring the x down with the power law, and I divide, and I get my answer correct too, 3 significant figures. Okay. Okay, I want you to do, okay, this is usually what they will do. Let's do number 2, because usually they will help you. They will tell you in A, get this so that you can continue in B. So that's usually the way that they will help you. Okay. Again, stop the video, and as soon as you are finished, you can continue the video. Okay, so I'm starting with number 2A. They say show that this can be written as this. So they actually helped you. So it's 2 to the power, let's just get it here. Let me just remind. So it's 2 to the power x plus 1 plus 6, and it's 2 to the power x minus 1 minus 12 is equal to 0. Okay. Okay, now let's do exactly the same like we did with the previous one. So we're going to break this up. So it's going to be 2 to the, we will now get the order correct. 2 to the power x, 2 to the power 1. It's better to put that one in front, but I'll do it now. Plus 6. Now, this is going to be 2 to the power x and 2 to the power negative 1. And I will now work with that. Just, I make a dot. It implies multiplication. Okay, now I'm going to just rearrange it. I'm going to put the 2 in front because that's the constant. And I think it's better if I put it in brackets, 2 to the power x. And you could have put it there also in brackets. I think that will be more the way that you are used to. Now, be careful. If this is 2 to the power negative 1, it's actually going to be a half because it's it's going to be, can I just show you? 2 to the power negative 1 is 1 over 2, which is a half, because you bring the 2. And if as soon as you divide there, the 6 by 2, you're going to get what? You're going to get the 3. Okay, so that 2 will give you 3. And then I have 2 to the power x. Okay? And minus 12. And that's equal to 0. And that's exactly what I did there. Okay, so I just made this a half. And then I take 6, multiply a half, and that will be 3. And that was number A. And then they will come with number B. Now, can I just say this to you? In the exams, if you struggle to get A correct, just leave it. Don't spend too much time on that. Continue with B, because you can still get marks in B. Continue with the correct answer. You have now. They say that, but you know that you are going to work with that one. So you're going to say 2x, and you see that trinomial now. Let's just see 2 to the power x. I just want to see 2 to the power x. No, it's not a trinomial. It's not a trinomial. How can I see it's not a trinomial? I'll show you now. If it was a trinomial, then this should have been 2x, and this is x. But this is exactly the same. So this is actually like terms. So you can say it's almost like y. So 2y plus 3y is 5y. So this is going to be 5 2 to the power x. Okay? And I can take the 12 over. So don't always think it's a trinomial, because the problem was it should there have a 2. This one must be double that exponent, always. But I can continue with it like this. So now I divide 5, so I have 2 to the power x equals 12 over 5. And I do exactly the same. I want to bring the x down, and if I want to bring the x down, I take logs on both sides. And then I bring the x to the front, the power log. And then I divide log 2, and I divide log 2. And I get my value of x. And now press on your calculator. Press log and make a bracket. If you see something becomes a bit complicated. So 12 log bracket, 12 divide 5, close the bracket. I would say equal, doesn't matter. Divide log 2. And correct to 3 significant figures, it's 1,26. And that is correct to 3 significant figures. Okay, and that was your answer, 1,26.